Good morning all of you. Today we are going to discuss about Fibonacci of a number. This particular problem statement we will solve using iteration and recursion. Coming to the problem statement, there are a lot of details are there. I will go specifically what is exact problem statement. Coming to given a number n and you need to find nth Fibonacci of the number. Whereas two basic important statements, Fibonacci of 0 is 0, Fibonacci of 1 is 1, then Fibonacci of nth number you can calculate sum of previous two Fibonacci numbers, that is Fibonacci of n equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. Coming to this Fibonacci of problem statement, what we discussed, Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2, where Fibonacci of 0 by default is 0, Fibonacci of 1 is by default is 1. This particular problem statement, if you want to solve using iteration, same block of steps, repeated execution, then what you will do, initial value you will take two variables, f of 0 that is 0 initial value, f of 1 that is 1 Fibonacci initial value 1, then you need to find f of n value you need to found. Using this loop you will found this f of n value. Now coming to 0 Fibonacci value you know, 1 Fibonacci value you know, from 2 onwards you have to found. So I value you will start from 2 and this will go till n including n. Every statement I value will be incremented by one step. For each iteration, what you will do, these three statements will execute. Now first, for instance, if you assume n value is given as 4, f of 0 value 0, f of 1 value is 1, f of nth value you have to found. I value initially you started with 2. Now this condition is true, then f of n is equal to f of 1 plus f of 0. So 0 plus 1 that is 1. Then f of 0 will be replaced as f of 1 that is 1. F of 1 will be replaced as f of n that is 1. I value again increment. Once I value increment, I value become 3. When I value is 3, then again you have to check I less than n or equal to n, condition is true. Then again calculate f of n is equal to f of 1 plus f of 0. F of 1 is 1, f of 0 is 0 is 1 that is 2. Now again replace f of 0 is f of 1 that is 1, f of 1 is that is f of n that is 2. Now again I value will be incremented. Now I value become 4. I is less than or equal to n, condition is true. Again f of n is equal to f of 1 plus f of 0 that is 1 plus 2 that is 3. Then f of 0 will be replaced as f of 1 that is 2. F of 1 is replaced with f of n that is 3. Now I value again increment. Now I value become 5. Then again check the condition, I less than or equal to n, condition is false. You will come out of the loop. F of n value will be returned. F of n value is 3. So 3 will be returned. That means that f of 4 value is equal to 3. Now if you see all the Fibonacci values, f of 0 value is 0, f of 1 value 1, f of 2 value is 1, f of 3 value, that is 2, f of 4 value, that is 3. Sum of two previous, right? That condition also satisfied. This is a iteration method. Coming to recursion method, a function call itself. Here also there is a loop, a block of statements has to execute repeatedly until a specific condition. What is a specific condition? If n value equal to 0 or n value equal to 1, that Fibonacci values are constant respectively 0 and 1. So that condition we will make it as termination condition for recursion. If this condition is met, then you return n respective value. Remaining cases, a function call itself, recursion it will go. Now coming to f of n value assume it as assigned as 4. Function assume Fibonacci I am writing as fib4. Now check the condition, f n value equal to 4. Whether n equal to 0 or n equal to 1, condition is true or false? Condition is false. Then what it will go to return fib of n minus 1, that is 3, plus operation fib of n minus 2, that is 2. Then first statement again will execute fib of, here n is equal to, here n value is 3, n minus 1 fib of 2, next plus fib of 1. Next again this particular statement again will execute fib of 2, that is fib of 1 plus fib of 0. Now check fib of 1, this condition is true. When this condition is true, n value will return. N, what is the n value here? What is the n value here? 1. That value will be returned here. Now right side of this particular function fib of 0, here this particular function, that condition n equal to 0 or n equal to 1 condition is true, it returns 0. So 1 plus 0, this value returns 1. Fib of 2, then 2 returns 1. This particular right side fib of 1, this particular function n value is 1, so it returns 1, this particular function. From here it returns 1, 1 plus 1, that is a 2. Fibonacci of 3 is 2. So this altogether returns 2. Right side of this particular Fibonacci of 4 we need to execute. Then Fibonacci of 2, this is 2 function calls Fibonacci of 1 plus Fibonacci of 0 will be executed. Here in this particular n value is 1, so when it is n value is 1, 1 will be returned. Here n value is 0, 0 will be returned. So 1 plus 0, this particular function will return 1. So this again, this function fib of 2 is 1, 1 will be returned here. 2 plus 1, 2 plus 1, 3. Finally 3 will be returned out of this particular function. 3 will be written out of this particular function. If you see, we already discussed recursion will take more amount of time compared to iteration. Why? Because here fib of 1, here one time executed, here fib of 1, one time it is executed, here fib of 0, one time it is executed, here fib of 0, one time it is executed, fib of 2, here one time it is executed, fib of 2 one time is executed, that means that same function will execute multiple of time. Because of time iteration, compared to iteration, recursion will take more amount of time. This is a one reason. So I hope you understood this. Thank you. If you have any doubts, please comment on the comment section. Thank you.